The name of this video is Effects on Perimeter as a Result of Dimensional Change. The content objective says we want to apply a scale factor to the dimensions of a figure to make observations about the effects of the figure's perimeter. Okay, so the scale factor, remember, it's the ratio of the lengths of two corresponding sides of similar polygons. So say I have two triangles here. I'll have a smaller one and I'll have a bigger one. And the corresponding sides are the sides that line up, and they line up by the angles. Corresponding or similar figures have to have the same angle measurements that correspond. So I have a 90 and a 90, and let's say this is 30. I don't know if you can read that, 30, and then this would be 60 and 60. But what we're really concerned about now are the lengths of the sides. So let's say that this is, let's make this one 3, 2, and 6. And so if these were similar figures, we would have to have a scale factor, something that we multiply by one number to get the corresponding side. So if the scale factor was 2, the side that corresponds with 2 would be here, and this would be 4. So 3 would be 6, and 6 times 2 is 12. So those would be my new lengths. Now the scale factor is what we multiply by. So let's pick two sides. So let's pick this side 2 and 4. Those are corresponding sides. The way you can find the scale factor is you just write them as a ratio. So I either have a scale factor of 2 over 4 or 4 over 2. The difference is which direction am I going? Let's simplify that to 1/2 and 2. So if I want to go from my smaller figure to my bigger figure, if I want to go from 2 to 4, well, if I multiply 2 times 4, if I multiply 2 times 2, I get 4. Going in the opposite direction, it's the reciprocal. If I multiply 4 times 1/2, I get 2. So the scale factor is the ratio of the two sides, and it just depends on the direction you're going. If you want your figure to get larger, you have to multiply by a number that is larger than 1. If you want your figure to get smaller, you have to multiply by a number between 0 and 1, so a fraction, not a negative number, but just the reciprocal of the other scale factor. Okay, let's look at the review of the scale factor here. What is the scale factor of quadrilateral WXYZ to quadrilateral EFGH? It's important that you look at the order here. They're not always drawn in the same orientation, but this similarity statement tells us what lines up. So W is my first letter here, so that has to line up with E. So here's E, and here's W, so those line up. I find it helpful to redraw the figures so that they look the same. And so if I go E, F, G, H, then over here I go W, X, Y, and Z. And then I can go back and fill in the measurements. So if between W and X is 10, so these are my first two, between E and F has to be the corresponding 2. Okay? So here are the measurements, 10. Between E and F is 10. Let me say that again. WX, between W and X is 10. So between W and X over here, I put a 10. So our scale factor, I have a 2 and I have a 10. So my scale factor is either 2 over 10 or 10 over 2. We'll go ahead and simplify that to 1/5 or 5. And it just depends on the direction. So the statement says, what is the scale factor of going from this one, the bigger one, to the smaller one? So if I want my number to get smaller, if I want to go from 10 to 2, I would multiply by 1/5, because that would make my number smaller. If they wanted me to go in the opposite direction, my scale factor would have been 5, because 2 times 5 is 10. So the scale factor is what do I multiply by 1/4? corresponding side to get the measurement of the other corresponding side. And it's worth noting here that the angle measurements have to line up. So if this is 55, this would have to be 55. And if this is 125, this one would have to be 125. This is a quadrilateral, and so opposite angles are congruent. And so we could go ahead and fill them all in if we needed to. We don't really need to do that right now. That's just a quick review. All right, let's look at a definition. Dimensional change. Dimensional change is the change in the measurement of the length in one direction. Then they remind us that width, depth, and height are all examples of dimension. And we have a picture here of a rectangular prism, and that's fine, but we're only going to be talking about perimeter today. So this is a three-dimensional figure. So let's go on and look at what comes next. All right. This says that if two polygons are similar with corresponding sides in the ratio of A to B, then the ratio of the perimeters are in the same A to B ratio. Okay, so let's look at this picture here. We have a triangle, and they give us the dimensions of 6, 6, and 14 on the smaller triangle. And then they tell us that we are going to have a scale factor, or we're going to multiply everything by 1.5. So 6 times 1.5 is 9. 6 times 1.5 is 9. And let's see, 14 times 1.5 is 21. Okay, they make a mistake here. When they add 6, 6, and 14, they get 20. It's obviously not 20, that's 26. So the original perimeter and the new perimeter have the same scale factor. So if you take 26 and multiply by 1.5, you get 39. So with perimeter, the dimensional change is the same as each side. So if the dimensional change or the scale factor from 6 to 9 is 1.5, then the perimeter would have the exact same dimensional change. Excuse me. All right. So we have a 5 by 7 inch photograph. I'm going to get rid of this hint. I don't think that's the best way to do this. You have a 5 by 7 photograph. So let me just draw a photograph that is 5 by 7. And then it says it currently has a 2-inch frame. So let me put a 2-inch frame around that. And so I would be adding 2 going this way and this way. So 7, 8, 9. So that would make this 11. And 5, I go 2 this way and 2 this way. So that is 9. So my perimeter of this with the frame around it would be 22, 18 would be 40. Okay. So now the photograph is going to be matted to produce twice the size needed to frame it. Okay. I'm going to go ahead, just because I think it's a little confusing, I'm going to go ahead and use the picture with the frame, okay? Let's go ahead and use the picture that's already framed. So I'm going to use the dimensions of 9 and 11. And now I want to mat that. So let me use another one, but I'm going to double. So if I double 11, I'm going to have 22. And if I double 9, I'm going to have 18. So if we add these up, our new dimensions, 22 plus 22 plus 18 plus 18 is 80. And so you can see that the new dimension, again, I included the frame, is double. Okay, so if each side is doubled, if 9 and 18 is doubled, and we add up all of the perimeter will also be double. So the new picture would be 80 inches around. Okay, let's look at the next example. A rectangle has a length of 21 feet and a perimeter of 70. So let's see, we have a length of 21, so it'd be 21 here, has a perimeter of 70. So we don't know what this is, but we know when we add everything up we get 70. So we can just say 21 and 21 is 42 plus 2x is going to be equal to 70. If we subtract 70 minus 42, we get 28. So 2x is 28, and so x is 14. So that means that this x here becomes 14. So we have a dimension here of this of 21 and 14. What is the perimeter of a similar rectangle with a width of 10? This one's going to be a little bit smaller. And the width is 10. And so what we know is that if these are similar, and they say they're similar, that they have a scale factor. So I have a 14 and a 10 that line up. So my scale factor is either 14 over 10 or 10 over 14. Let's go ahead and simplify that to 7 over 5 or 5 over 7. And so it just depends on which direction we are going. So what I'm saying is if I was to multiply 14 and I want to get smaller to 10, I would multiply by 5 over 7. So I'll take my calculator. 14 times 5 divided by 7 is 10. So if I want to know what the length over here is going to be, I'm just going to take my 21 and multiply by 5 over 7. And 21 times 5 divided by 7 is 15. And so now I have my new dimensions. So this is 10, this is 15, and so the new perimeter is going to be 15 plus 15, 30, 40, 50. Okay? And so let's go ahead and see what was our old perimeter. It was 70. So if you take 70 and multiply that by 5 divided by 7, you will get 50. So the perimeter, the scale factor, or the dimensional change is going to be the same with the perimeter as it is for each side. And that is the end of the lesson. So it's a pretty short lesson. So I'm going to post this, and then please work on the independent practice.